So we have another application dealing with continuous interest. Just reviewing the formula. I would know right away that we're using this particular formula based on the fact that they say compounded but continuously. So I know right away what to start with. Future value equals principal times E taken to the R times T power. Now, the theme of this section really, we're plugging in for every variable. We're going to be missing one variable that we're asked to find. So we'll just go through and see what we can plug into the formula. So we're asking ourselves, how long will it take an investment of $10,000? So investment is your principal. So that's going to start off with $10,000. E is E. To double, and I'll get back to that in 1 second. If it's invested at 2.3%, so that's going to leave us with, that's our R in a sense. We're actually going to have to move the decimal over. So 0.023, compounded continuously. So the how long part, the how long is our variable T, that's what we're looking for, time. So that implies that we would need to figure out that there is a value for future value, F. And then they didn't straightforward give it to us, but in a sense, they wanted us to think a little bit. So just kind of note to yourself, if you're gonna look at your future value, note, you're doubling $10,000. And if you double $10,000, you're multiplying 10,000 times 2. So that's going to actually tell us that the F is 20,000. Keep in mind, they'll change this up on you. What if you want to triple it? What if you want to have it? What if you want to reduce it? So just kind of look out for the keywords. In this case, it was double. Now, before we go further, what's a little different in these particular applications in this section is that your variable is no longer already solved for. You have to apply algebraic techniques to isolate your variable. So if you want to look at this a little bit closer, that T is located in the spot of the exponent. So this is an exponential equation. So it's a little note for ourselves. And we know all of the techniques of solving exponential equations, or at least we've practiced them and we'll work on them as we go. What I want to look for is before I try to match bases or isolate the exponent part, one of the tricks that we have not seen quite yet is we want to make sure we isolate the exponent expression first. So let me see if I can write that in. That's kind of different than what we really saw in any of the examples in the previous section. And the exponential expression in our sense is E to the 0.023t. Now, if you want to isolate that, you just think about what's hanging out right next to it is 10,000 times. So if you're going to undo multiplication, what we're going to do is we're going to divide both sides by 10,000. So we have to do this first before we approach it with any of the techniques we've learned from our previous sections. Now this is really nice, 20,000 divided by 10,000. In this case, it's going to give us a 2. And then we know the 10,000s divide out. So now we have E to the 0.023t. And this might look familiar from your past or a few examples ago. If you want to isolate the t's, just the t, we are looking at the fact that we cannot match the bases. So this would be where I would take the natural log of both sides. And why natural log, you ask? Why not just log? Well, if you saw that E, that's kind of the key. That helps us have maybe a little bit of a nicer time when we're trying to deal with all the logs. You don't have to, but I guess if you follow my advice, it causes a little less steps to take later. So if I take the natural log of both sides, that's like me saying natural log of 2 equals natural log of e to the 0.023t. And anytime you take the natural log of both sides, the next property that goes hand in hand is what happens when you have log base b of x with an exponent in your argument. Remember, the idea is to move that exponent so that it's the coefficient of your logarithm. And so that's exactly what we're going to do. We're going to take this part, put it in the front. So we have 0.023t. And then rewrite everything we have not used. Natural log of 2 and natural log of e. And the next idea here, the reason why we took the natural log of both sides is that ln e, ooh, I love this. Natural log of e is equal to 1. So right away, that can get replaced. And what that essentially does is it's a little less complicated. We have 0.023t times 1, which is the same thing as 0.023t equals natural log of 2. And then if you're solving for t, all we have to do is divide both sides by the coefficient, 0.023. So here we get t equals natural log of 2 divided by 0.023. And t is in time. Remember, this is connected to a real life situation. So how long time, according to this situation with continuous interest, t is time in years. So you actually have units to this. You may want to add them in. But if this is a real life situation, the exact answer is not the best answer you're going to give your boss or even yourself when you actually want to know a number. So remember, this is the exact answer, and that's appropriate for algebra. But usually we'll be looking to approximate because it's a real life situation. So if we're going to approximate t, this is where we would pull our ti out. I'll switch over for you. I do have, it's natural log of 2. So natural log of 2 divided by, I'll recheck before I say anything. I think 0.023, yes. 0.023, be really careful with decimal. So we'll press enter, and you see you get this really long number. So that is 30.1368 or so. I'll write it out for you. And actually, if we're approximating, let's just go with 4 decimal places, and then we'll go from there. So 30.1368. 30.1638 years. And you don't really have to be too precise unless people are asking you to round to specific decimals. If we were to utilize this, yeah, I would say in this particular course, you could go further and just say, as long as you know it's not just an exact 30 years, so maybe 30.2 years would be appropriate. However, in some of your future math classes, maybe you're going to use this t value for something else. So if you ever have to use a value for a future calculation, what you want to do is you probably stick with the exact answer. But like I said, for our purposes, we're going to go with the approximate answer because we are done. There's nothing else to figure out. And plus, it's so much nicer to think in 30 years about, as opposed to ln2 divided by 0.023 years. That really makes no sense. So answer these with approximations. Just be careful if they ask for particular decimal places to round to. Hope this helps. I will see you in the next example.